Hello, Galilea and Daniela, good morning. So I'm going to record part 2 of the poster making after sleeping a little. I'm much refreshed this morning. Okay, here we go. So let's start. All right, hold on. Let's go to the poster itself, right? So we are at the level of the graph or plot. Yeah, this machine is a little slow on switching from window to window. Just need to wait patiently. Here's the poster. Okay. And here's the graph. Let's go a little more centered to the middle of the poster. We're in the second section of the poster. Well, we have essentially the materials and methods, and this includes essentially the data, right? The collected data, and a little bit of the manipulation of the data. When we say manipulation of the data, it doesn't mean necessarily in a negative sense that we are mismanipulating the data, all right? Manipulation of the data is simply ordering the data, the raw data, ordering it around so that it's more informative. For example, when we gathered all the nations with their populations and surface area, okay, you know that each one of you had about 50 countries to deal with, so you each did that, and then you sent me your spreadsheets, and then I compiled one master list of the 5 spreadsheets that you gave me. So that's probably the first level of manipulation, for example, to combine and to come up with one master list from 5 Excel spreadsheets, 5 spreadsheets with about 50 countries each. I collated all those into one master list. So that's the first level of manipulation, if you will. Then once I had that master list, it had 3 columns, right? Population, and it had, it had the name of the nation, the amount of people in that nation, which we call population, and then we had the surface area in the square kilometers of units. All right, so those 3 columns, then ranking them or sorting, like I was explaining in the first video, that's another level of manipulation. So when I ranked those nations from alphabetically from A to Z, all right, and or sorted them from A to Z, that's a manipulation of the data because we are doing something to the data. Okay, we're doing something by hand, if you will, by hand, by the mouse, on the computer. So that is manipulation of the data. It doesn't mean that we are manipulating it in a bad sense, in a wrong sense. That would be a mismanipulation, and that's unethical. Okay, if we fudge the numbers, if we change the numbers, for example, if we change the number of people on a particular country and we change it because of some ideology, we put either more people or fewer people just because of ideology, because of a particular agenda, then that's mismanipulation and that's unethical, okay? But the manipulation itself is just playing around with the data so that it's more informative, so that there's an order to it. And then when we did when we estimated, when we calculated the density, for example, that's a manipulation of the data because we did not get densities from the internet. We calculated it themselves. So that 4th column of population density, that was a manipulation, if you will, of the population, the total number of people divided by the surface area, okay? The next level, for example, is to make the graphs, to generate these graphs, these plots. That's another manipulation, right? So when you hear about manipulating the data, you have to make a distinction between the proper manipulation of the data, which also always needs to happen in order to make some sense out of it, to organize it so that it's informative. That's one thing. A different thing would be to mismanipulate it, to put things that are not true in there, and then that's unethical, of course. Okay, so let me show you how to generate these graphs. I'm going to close this one. I'm going to eliminate it because that's the one I'm going to generate now. All right, so we're going to generate a graph which has the ranking. We want to see how the data behaves. We want to see how population density behaves, all right? And that's a term also used in science, how the data is behaving. In other words, we want to visualize the data in some way that it's informative, that it tells us something. What kind of distribution, we can ask, what kind of distribution are we going to get on population density if we rank the density from the highest density to the lowest density? And I had done that last night already. So here I have population density, all right, by the most dense. It's ordered, it's ranked, it's sorted from the most dense country, which we know is Monaco, with almost 20,000 people per square kilometer. That's the highest number, down to the lowest density, which are these three areas, the Falkland Islands, Greenland, and Antarctica, which, according to the websites that you people search, they had no stable population. I'm surprised about Greenland because Greenland has people living in them year round. So anyway, I don't know why we came up with 0 here, but that's what the data is for now. We're going to go with it. Certainly Antarctica, as far as I know, has no stable population. There are scientists who go seasonally there, but no one who actually lives there year round, as far as I know. Anyway, you can see that this is the bottom of the list, and these are the low numbers of population density, persons per square kilometer. All right, so we're going to generate a graph out of this. Again, you go to the bottom. The first thing we need to do is we need to highlight the data. And the only data that we're using for generating this graph is the density data, okay? So I go to the last cell here in Antarctica, 0 population density, and there I click, hold the left click on the mouse and drag up. Okay, so I highlight all the way. You see how I'm pushing my cursor all the way up to the top of the Excel spreadsheet, okay? And then come down because I don't want to include, I do not want to include the title, pop density per kilometer square. I don't want to include that in the graph. That is not informative, that is not a number, okay? So I don't want to include that title there. And so I stop at the highest cell here that is informative, that has a density, which is Monaco with 19,000 people, okay? Release the left click, and now the densities are highlighted. That means that they're active. They're active and they're ready to be manipulated, to do something with them. All right, so now I go up to the tabs, up on top of the spreadsheet on the tabs, and I look for data, the data tab, click into the data tab. Is it here? Maybe not. Maybe it's in insert. I think it's in insert tab. Let's go to insert tab. I'm looking for graphs. Yeah, here we go. Okay, so in insert, here we have charts, plots, graphs, all right? And we're going to select from here, we're going to select the line chart. So this is a line or area chart. You see, it's a little icon, line chart. And it also has a menu that you can choose here. We're going to choose the first one on the left, and it gives you a preview window. When you mouse over the icon, behind it gives you a preview window, all right? You can see it appear there. So that's the one we want. And right away we see on the preview window that we're getting what is known as a power law distribution. Very interesting, a power law distribution. I had talked about the power law already in previous videos. You click into that one and it gives us the actual chart. So here it is. Let me scroll down a little bit so I have more space. Try to make it as large as possible here by dragging the corners. All right, so this is kind of the raw chart, the basic chart that we need to manipulate precisely to make it a little more informative and more clean for presentation purposes. All right, so the first thing we notice is the blue line, which is illustrating the, or graphing the population densities of the world, the 230 of them. And we see that on the x-axis is the ranking status, All right, so the ranking status is that number 1 down here on the x-axis near 0. So it goes from 0 out, right? 0 is on the x-axis, where the x-axis and the y-axis meet or intercept, that is 0 on both scales, either on the x or the y-axis scale. All right, so let's see that the first country ranking number 1 would be the highest density, right? Highest density, ranking number 1, and that is, again, going to be Monaco here with close to 20,000 people per square kilometer, okay? So we have the independent variable is going to be the ranking number from 1 to 230 on the x-axis. And then the dependent variable is going to be the y-axis, meaning the specific density of that country. So let's say that in the ranking, country number 1, the mostest country is Monaco, all right? So that has the specific value of 20,000. It could have been 8,000 or it could have been 50,000, you know, but this is the actual data from the numbers experimentally. That's the actual data that we got. So that is going to be the y-axis, because the y-axis is dependent on the x. In other words, the number, the density of each country is dependent on the ranking, right? Where they fall on the on sorting the data from highest to lowest density. Okay, so in other words, it's just under 20,000, right? 19,000 is just under 20,000. And you notice that the scale on the y-axis goes 5,000 units at a time, 5,000. Okay, so that's a pretty high scale, if you will. It's the numbers are pretty high, the intervals, right? From 0 to 5,000, from 5 to 10,000, 15, 20,000, 25,000. But you notice that the highest ranking is 19,000, just under 20,000. So we don't really need to go all the way to 25,000. We don't need to go all the way up to 20,000. We can stop our graph at 20,000. In other words, we can make the maximum limit on this graph on the y-axis to be 20,000, and that will include all of the data. That will not leave any data out. So we can format that, and we just mouse over the y-axis values then and click in, and you see now that activates the y-axis. Then right-click and go to, let's see which one here is not select data. Format axis. Okay, let's try format axis in this little drop-down menu here. Now, probably you already know all this stuff, especially if you have taken the course on Microsoft Office, but in case you don't know this stuff, okay, so here I'm teaching it to you. All right, so on that little drop-down menu, which again, you click into the y-axis, like next to a number, right-click, and it will give you a drop-down menu. There's a drop-down menu. Then select Format Axis. And on the right-hand side, it gives you these options here, all right? So we want to see bounds. You see Axis Options, the bounds or the boundary. We start at 0, but then the maximum, you see how 25,000 is here. We want to make that 20,000. So you can go in there and click in to the number, erase the 5, put it 0 instead, and let's see if that does it. You can keep the scale to go 5,000 at a time, that's fine. And then if it has an option, okay, so I put in now 20,000 and maybe enter. Let's see if that works. Yeah, okay, that worked, good. And you see how now our graph changed, right? The y-axis, now the maximum is 20,000. That was pretty simple, straightforward, okay? So you can manipulate each segment of the chart to make it more informative, more illustrative, to make it the way you want to. All right, on the x-axis, we have the opposite problem. We have the chart only going up to 225 here, but we want to include 230. So let's widen this graph a little bit. Just pull on the middle bubble, the middle circle on the margin. You see the margin of the chart here? I hope that you can see my cursor moving around. And so you can pull on the middle circle on the margin, and you can expand or compress the chart. You see, we want to expand it a little bit according to the amount of window that you have in your on your computer on the desktop. And now we want to expand this margin. We want to give a few more values to the x-axis in order to include every piece of data, because you see that our data points, our graph, our plot is actually running off the x-axis, all right? So we want to rescue whatever data is there. So we do the same, right-click on the x-axis numbers, the ranking, choose Format Axis, and now let's see if we get a different, it's just giving us category number, maybe try number down here. It's a question of exploring a little bit. I want to put a little more the scale. It's a little different window than the previous one. Axis option. Horizontal, yes. Let me see, axis type, vertical axis crosses, add category number. Okay, add maximum category. Let's try that. There we go. Oh no. Okay, we need to hunt here. Maybe under tick marks. Here. No, this is the mark itself, the tick mark. I'm going to pause the recording for a moment until I find out how to expand that x-axis, okay? Okay, I found out what the issue is. It's not on that tab of the x-axis. I had told you to do something similar to what we did with the y-axis, which is to highlight the ranking number, right? To highlight the x-axis, and then to right-click and to go format axis. But it's giving us different options because it is the x-axis, which is independent. It doesn't, it's not here where we need to increase the number. It's already increased automatically. It's increased automatically to include all the data. So the issue is different. It's only showing 226 over here, and then the data runs off the graph, if you will, to the right, simply because this is too compressed. The desktop screen, the size of the screen is kind of small. So if I simply highlight the whole graph as a whole, click somewhere outside near the margin, click near the margin of the graph. Let's say, so here's the graph, okay? Click near the margin where there's blank space to highlight the graph as a whole, right? So now the graph is highlighted. You can see that it has its margins. Then just grab a corner. I'm grabbing the lower right corner, grab it and drag and expand. So expand the graph from the bottom. Okay, and for me, I have to move the screen over because I run out of screen here. And now you see, if I keep expanding here to the right, on the bottom, the x-axis, now the numbers are appearing. Actually, a little too tight. Let me go back a little bit. Where he gave me, there. All right, so now you can see that it's gone up to 229. And that is actually because the last three numbers are zeros, which are going to be really on the x-axis. And so the scale here is every three numbers of ranking, 223, 226, 229, right? So the scale here. And the next number would be 232, but we only have 230. And so that's what is showing here. If I were to pull this x-axis further out, if I were to pull the graph, stretch it out further to the right, at some point, eventually this scale will fit the 232 there and would have the very last point included. But that's good enough. It's just a question of the size of the graph, the actual, the width of the graph horizontally, because it's 230 data points that are on the x-axis. So you think about it, 230 points, that's a lot of points down there, okay? So that's the issue on how to get that, the full scale number to show up. But the data is all there, okay? So the graph does have integrity. The data is all there. All right, let me pull the graph down here a little bit. So now we got the X and the Y axis numbers the way we want them. Now we want to label those axes, all right? So we want to label the axis. Again, with your chart highlighted, right click on it, right click, and go to Format Chart Area, Format Chart Area. Okay, let me see. Text options. Nope. Let me try the tab up here. In Format, I'm looking for the type. Oh, maybe I have to click inside. Yeah, I have to click inside the chart. Okay. Format plot area. Let me see. Yeah, I think if I click inside the chart anywhere inside the actual plot, okay, that activates the plot itself. Let's try Format Plot Area. I'm looking for titles. Orders. No, not here. Where are titles? Maybe it is back on each axis. Let me see. Format axis should be one tab with text option. Axis labels. Next to axis. There's a title. Where is the title? Okay, let me stop this for a moment again. Okay, so I found the tab. Uh, when you have your chart highlighted, go to the tabs on top of the spreadsheet to design. Design, chart tools, design, and then the first one on the left, the first option, add chart element. Add chart element. Click in there, drop down menu, and the axis title. Axis title, primary horizontal, primary vertical. So let's start with the primary horizontal. All right, and there's the little window. Now we need to click into the little box, the text box. You see it at the bottom, halfway down on the horizontal axis. You click in that little text box that's active and erase what it says there, axis title, and you type in, so this is ranking. Ranking, all right. And then click outside, and that's done. Go back again to the add chart element on the upper left, click in, drop down menu. Now axis titles, primary vertical on the y-axis, and there you want to type density, right? So you can just type density, and you should put the scale in parentheses, which is persons per kilometer. Where's the caret? Top of the 6 square. All right, click outside, and there is your y-axis title, density in persons per kilometer square. All right, so next we're going to, so you can leave the blue if you want. I'll show you how to, oh no, let's, yeah, we want to make this more informative. So let's see, since we're at the titles, let's put the title, the chart title there. Just directly click into the chart title name, erase, and put, what did we put? Hold on a second. Mine is drawing blanks. Population density distribution. All right, so go back to the graph here. Population density distribution. Okay, so now you have that title of the chart as a whole, the graph. Oh, you want to keep saving periodically, so hit the save button there. On the upper left, the icon of save. You want to be saving this periodically. Okay, now, a few more things. Let's work on the trend line. To get it, first we want to make our data series, the plot itself, the line that connects our data points, which is now in blue. We want to make it black and a little thicker. So click into the line, click right into the line, and that highlights, that activates the actual data points, the data graph, right, the data plot. And so now right click, once you have it activated, right click, and again, format data series. So let's go there for a moment, format. Let's see, series options, color, the little bucket of the color. And we want to have a solid line. You can leave it on automatic. Color, instead of blue, which is the default, you choose black. And then increase the width, the point. Let's make it 3.5, 3.5 point, so that it shows a little bit more. All right, and that's it. You can click outside and then discard that. Okay, now we have, you see the data points are, the actual graph itself is thicker and in black. And now we want to do the trend line. So go back to that plot area, the graph, highlight it again, click into it, and then right click. And you see on the drop-down menu, add trend line, add trend line. And again, it gives you a little menu here on the right. So it shows you that right now the trend line, that is the default trend line, is linear, which you can see it down here, okay, in this light blue, the dash blue line. Let's do something. Let's format it first so that you can see it better. So go to the bucket, leave it at linear for now, but go to the bucket, make it red in color, and also increase the dash point to, let's say, 3. Okay, so now you can see it better. And now let's go back to the graph itself here. All right, the options, so trendline options. You see that the default is linear, the second option, and linear is a straight line. So this is the best fit straight line for our data points, which is a lousy fit, right? You can see it's a lousy fit, and therefore we're not going to use that. So let's start from the top, exponential. Let's try the different options. So click into exponential. It's a little better, but it's totally missing the high points, the few high points, the dozen countries that are on the rise of our plot. Okay, so exponential is better than linear, but not the best. Let's keep going down, logarithmic. Logarithmic is getting better, is reaching more points, okay? It's fitting better, but it's still not the best. So let's continue. Polynomial. No, polynomial is worse, it went down. Now let's try power, which is the next one. Bingo, there it is. You see now the power law distribution is the best trend line, the best distribution for our graph, okay? It is the best one there. Finally, if you want to do moving average here, but that's, yeah, but the problem with moving average is that it's adjusting, the trend line is adjusting to the data, so it really does match the data, but it stays short, it excludes the highest point, which is way off the scale, this 20,000, the 19,000 density of Monaco excluded, and so it doesn't represent all of the data, okay? And kind of the moving average kind of leaves out the outlier. So we need to go back to power. And power includes all of the data, as you can see from here. And then if you were to go to the opposite end of the chart on the right side, as soon as the window goes down, here, grab the bar, you can see that the red, you can barely see it, but the red goes all the way to the end of the data on the right-hand side of the x-axis, okay? So bottom line, the power distribution is the one that describes our data best, the trend. So it is a power distribution trend, which is very interesting to see that it fits this kind of trend, the densities. Many rankings, many ordering, many sorting in nature follows this kind of power distribution. It could be the height of trees in a forest of each species, etc. Many different types of ranking or sorting of data in nature fits a power like a trend line, okay? All right. So that's informative because we see that the long tail is essentially x to the 1, x to the 1.1, x to the 1.2, 1.3, 1.4, etc. till we get to x to the 2, and then x to the 2.1, x to the 2.3, etc. Until we get to x cubed, x to the 3, right? And then 3.1, 3.2, 3.5, the exponent keeps increasing until we start going in a very fast. It's a log of a log, if you will, because it's going to go from x to the third power, x to the fourth power, x to the fifth power, but all the decimals in between also. So that will smooth it out, okay? Now these are actual data points, and that's why this is the best fit. But if we had exact numbers on the trend line, that is the kind of distribution that is happening. That is the algebraic formula, if you will. It is increasing the exponent linearly, and the effect of that linear increase on the exponent is this kind of distribution where you have the vast majority of data points, of items, are on the long tail, on the horizontal axis. That's the vast majority of them, because it's kind of it's a lag phase. It's increasing very slowly, just variance of x to the first power. And then when it starts duplicating, x squared, and then duplicate again, or raise the exponent, x cubed, x to the fourth, x to the fifth, you see that the log is going to pick up. It's going to go from lag to log phase, logarithmic phase, but it's not a constant logarithmic phase, it's an increasing logarithmic phase, all right? Until it goes very high here, x to the n. When n approaches infinity, if you will, you're going to get this one is known as asymptotic curve. I think I talked about that last time. Asymptotic is that it's approximating the y-axis, because you have x to the n when n is approaching infinity. In other words, it increases exponentially, and that line becomes essentially vertical, almost vertical, essentially vertical, until it includes all of the data points. At some point, the trend line needs to stop because we run out of data points, okay? So that's the definition, or that's the explanation of this power law distribution. And that's informative because essentially it's telling us that we have three regions on the graph. We have the region of the very few countries that are going exponentially, x to the n, all right? And those are typically very few at the lead, at the head of the ranking. And for us, it's about a dozen countries here, x to the n. Very high n value. Then we have the mid-region, the transition from vertical to horizontal, essentially vertical to essentially horizontal. We have a transition area, excuse me, where that n, if we're going backwards on the graph, that n is diminishing, is approximating 1. Okay, the x to the n, the exponent, is going from, let's say, from approximating infinity in the opposite direction to approximating 1, right? Because we know that x to the 1 is equal to x. So that's the transition area here. And then we get into the long tail, very long tail, which are the different decimals or centésimals, if you will, of x to the 1, all right? X to the 1.1, x to the 1.2, x to the 1.3, and you can break it down, that's at the decimal level. At the centesimal level, it would be x to the 1.11, x to the 1.12, 1.13, etc. And you can break it down into as many millésimals as you want, as many decimal figures as you want. And that's the transition here, essentially from x to the square, x to the 2, to x to the 1 is what is this very, very long tail here, okay? And most data points fall in that long tail. So we can say that essentially the data is behaving in three different ways, three different types of behavior. It has this horizontal behavior, if you will, that most of the data points are between x to the 1 and x squared. Then we have the transition area, okay? And finally, we have the rise of very few countries on the rise, which are the countries that are approximating x to the n when n is approximating infinity. So this gives us essentially three types of behavior of our data depending on what specific density it is. And that's interesting and informative for us because then we can parse our data, we can segment our data into three parts just for this. Keep in mind that this is an initial study, okay? With this just getting our feet wet into the data. There's much more analysis, statistical analysis that could be done with our data, but now we're just getting our feet wet. And so we can parse it into three regions. We can parse it into the countries that are essentially on the horizontal axis here that are behaving, let's say, horizontally, okay, behaving the same, which looks like from this graph, it looks like a linear trend line because it's pretty straight and flat down here on the horizontal axis. That's one group of countries, which is the majority of countries. Then we have the few countries that are in the transition region. I'm going to say, let's say when it starts curving here more or less around in the 40s, countries in the ranking 30, 40, between 30 and 40, it starts bending, okay, it starts bending. So we subtract 40 from 230, we're at about, we can say that the horizontal, let's call these the horizontal countries, are about 180, 190 of them. Then we have the transition countries, right, from the 40s into the dozen, which is actually 11 countries. But the dozen countries are the ones that are on the rise, mostly on the rise, okay? And so the transition countries, the ones that are on the curve, that's another category there, the transition countries. And then we have essentially the vertical countries, the dozen countries that are mostly on the rise of the curve, mostly vertical. So that's our three categories. When we look at the data itself, we see that those two boundaries, the boundary between the horizontal and the transition, is around 200 density, 200 people per square kilometer, around 200, okay? And then the upper transition from the curve into essentially vertical, it's the density is about 1,000. So what I'm trying to say again is that from the data, we can establish rough boundaries of the transition zone on the lower end, about 200. So going from transition to flat to horizontal, the density is about 200. And going from the transition to vertical, the transition is around 1,000, more or less, density, okay? And therefore, those are our two boundaries, and we tested then the three groups of data, densities above 1,000, densities between 200 and 1,000, and then densities below 200. And that's the data that we analyzed. We crunched in StatCrunch to see if there was, what you might call it, a correlation or not, all right? A couple of more things on this video to clean it up. We want to get rid of these horizontal lines, for example, okay? Oh, before that, we want to label the data points themselves, the black line, and we also want to label the trend line. So highlight the plot, highlight the black line, the data points, and right click, and let's see if we can add data labels here, add data label. All right, so that should bring up a little window. Where is it? No, that's not the one that I want. Go back in there. Try to get a grip on the, there. Format data series. So to label our data points on the graph, click the data itself, the black line, and right click and choose select data. On the little drop-down menu, choose select data. And now here you see series 1 is highlighted, and we just want to get rid of that series 1. Edit and edit. Now you put the name, and this is going to be, we put population density, pop density. Okay, click OK, and OK again. And that should appear, the label, somewhere in here. It's not appearing. It should appear as series 1. Let's try it again. Select data. Okay, population density. Legend. There it is. Okay, so we have now the population density here. We can move it into the chart. And it has given us the labels. Then we want to get rid of these horizontal lines. Okay, horizontal lines. So click into the chart area and right click again and format plot area. Here it should give us an option to get rid of the lines. No line. Oh, that's the border. We want the horizontal axis. We're looking for the, maybe it's under the format here, or design. Okay, so for getting rid of the horizontal lines inside the graph area here, click into the chart, click actually on a line, click on a line, and you see that it activates them. You see the little blue dots, the little blue circles. So it activates the grid line. Now right click on it and format grid lines. Format grid line, no line, no line. And then close. And then the lines are gone. Okay, so now we have, we can move the, we can move the title inside the graph. See, now we have our graph with the title of the graph, the legend of the graph. For the solid black line is population density, and the dotted red line is the power trend line. Then we have the title of the axes. We have the x-axis labeled as ranking from 1 to 229, and the y-axis labeled as density from, again, 0 to 20,000. So now our graph is ready for export. So again, you click into the white area of the graph to highlight the graph as a whole, and then right-click, copy. And once you copy, then you're ready to go over to the poster. And let's move down a little bit here on the poster. Okay, I'm going to erase all of this previous data that I had here. Just highlight and erase, highlight and delete. And now right click and paste. Try the first option, should paste the graph in there. There it is, there is the graph, the plot. Let's move down a little bit into the blank space and just grab the graph and bring it down to where you want it on the poster. Okay. And then you can make it bigger again by the corners, pulling on the corners of the graph. And you can, again, manipulate it here in the sense of sizing it, making it the right size that you want, move it around. All right, you want it to line up with the margins of the upper, of the margins of that middle section there. Okay, so you can move it where you want it. Click outside to see how it looks. And there is the plot, okay, the graph, and then the label, the title underneath. I have to stop recording now because I have to get going and teach at the university. So I'm going to stop this recording and send you this video a little later on. All right, thanks again. Bye-bye.